Alright, so once again, good day, grade 10. So this recorded video, the purpose of this video to have the continuation of our lesson for the limits, no? Though we only have few slides to discuss with, but I want to share you how to deal with them, alright? So for that, let's have our opening prayer. In the name of the Father, the Son, to the Holy Spirit. Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joaquin, and Saint Anne, and guardian angel, intercede for me so that I may be deserved to be helped today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright, so before we deal in the continuation, let's first review of what we have discussed last time. Now, with regards to limits, when we say limits, no, it only shows that in a graph there is specific limitation of a certain value, no, and from a limit, we were able to discuss as well some of the condition if, no, if a limit does not exist. Okay po. Okay, so if the conditions falls under this, does not exist po. Okay po? Alright, so if a function approaches a different number from the right side, so what we had last time with this slide, no, from the left side and right side of the zero, alright, so we have separate value. From the last example of this condition, let's have this example where we could see, no, the limitation of this function, no, of the absolute value of x over x as x approaches to 0, no, when it will become 0, this couldn't be simple as 0 over 0, because when we say 0 over 0, that is undefined. Okay, please take note of that one, ha, undefined. When a function or a fraction formed with 1 over 0, this is what we called as indeterminate. Indeterminate. And when we have 0 over 1, this is what we call as 0. Okay, but this has the equivalence of 0. But this one, this is indeterminate. This is undefined. Now, let's deal with the best thing. Limitation, we cannot just deal with undefined when you just simply substitute the value of your x to all your x's, the value will come up with the absolute value of 0 over 0, and we know that it would become 0 over 0, and that is undefined. So let us try things out. So what if, no, what if we tried, no, from this graph, no, from this graph, what if we tried, no, if the x, or the x, yes po, the x, no, would have the limitation of x approaches to 1. If this function, no, has the limitation of it as x approaches to 1, what would it looks like? When you have limitation of this function x, the absolute value of x over x as x approaches to 1, what would be the value? Of course, we're going to substitute the 1 to all of your x's, and that would become absolute value of 1 over 1. Now, when we are dealing in absolute value, no, it could fall on to negative values and positive values, correct? Alright, negative values and positive values. So let's try with the limitation of the negative values. What if your limitation as x approaches to 1 from your negative, no? It will become negative 1 absolute value over negative 1. Okay po? And we know that the absolute value of negative 1 is just simple as 1 over negative 1, or it has the equivalence of negative 1. Okay po? While in the positive side, again, this is the negative side, ha? While in the positive side, the limitation of this certain function as x approaches to positive 1, if we have that positive 1 all over positive 1 as well, the answer is 1. So if you will notice, there are two values that are not the same. So this is what we are dealing in the conditions wherein the limits fail to exist. If they have that kind of limit that has different values from the right side and from the left side, it only means that your limit does not exist. Alright, so let's deal with the topic that we are going to discuss for this day. So this will be quick. So we're going to tackle about properties of limits and direct substitution. Though we discussed this one as well last time, when we are dealing in limitation, uh, the concept of this one is similarly from what you have learned way back before, no, when you are in elementary and in your seventh level po, or grade 7 level, no. So basically, if we saw a certain value from your x, or from the limitation of your function as x approaches to something, all right, or a certain number, no? Therefore, you're just going to substitute the value of your x to your x. Okay po? So, here is the basic limits that you could see. When we have the basic limits of b, let b would be a real number or a constant number. Okay po? So, with this idea, no, while you have this basic limits already, I'm going to show you an example already, so that you will be aware of what are the things or how things are happening with this part, so that you might be able to get and cope with what how is the thing is going on. So let's have 5x plus 3, and let's just say this is your function, no? Let's just say this is your function, and let's just say you have 5x, and let's just say you have 3x, 3 only, 3. Let's have 3 only. The function would be 3. Okay, and let's just say you simply have, let's just say you have 5x plus 3x, and this is your function. What is the limitation of this function? What is the limitation of this function as x approaches to 2? So in the concept, what I mentioned a while ago, from the concept of substitution, this limitation as x approaches to 2 is just similar, wherein you just need to substitute the value of x to all of the x's of your function. So therefore, if you're going to substitute the value of x as x approaches to 2 to your function, that would become 5. Instead of putting x, that would become 2 plus 3. Okay po? So 5 times 2, the answer is 10, plus 3, and the value of your limitation is 13 po. Okay po? Next, how about what is the limitation of your function 5x, no, as x approaches to 2? Okay, so how is this one? So that would become simply direct substitution. I know you know it already, no? I know you know how to direct substitution, but let us first deal with this one. If you will be substituting it, it would become 5x, supposed to be 5x, right? But instead of putting x, no, you will be substituting it by, what's the value of your x? It is 2. Alright, so therefore, the value of your limit, as your function is 5x, your limit would become 10. Okay po? Alright, so how about this next the next function? What would be the limitation of this function 3, no, as x approaches to 2? At the first place, we could see that this is a constant number. Again, what is a constant number? In a polynomial, when you have 3x squared plus x plus 2, this is a polynomial, correct? Which has three terms. In the first and second term, with the first two terms, no, they are having both coefficients. They have both variables and they have both coefficients, right? So, the third term, we already know that this is our constant because we know that constant doesn't contain any variables. Okay po? Variables. Alright, so therefore, this is where when you have a function of a constant, for example, this one, can you see any variable with it? None. So therefore, if you don't have any variable, you don't have to substitute anything. So therefore, the value of your limit would become simply as 3. Okay po? And let's try to deal what is this basic limits. This is what we called as constant function. Okay po? When you have a constant number, okay po, again, the letter B, when you have a constant number which is B, and you try to substitute a specific or certain value, no, of your x to a constant number, the value of your limit would be essentially simple as the constant number itself po. Okay po? Alright. So how about when we have a variable? There you go. Alright. So when we have a variable, we just simply directly substitute the value of your x to the value of your x on your function po. Okay po? If the limitation is something like the limitation of your function as y approaches to 2. So therefore, you just look for the values of y and substitute the values of y as whatever specific number that the limitation is preferring. Okay po? So this is what we call as identity function. So the place that we are doing a while ago, we are substituting the value of x to your 5x. The value of that one is identity function. So from the identity of x, you just substitute it to the identity of x. What is the identity of x? Of course, x as well. You look for the similar term of edx, and that is just simply as x. Look for all x's. Okay po? So what if, Sir Jai, you have this, let's just say, sige po, let's just deal with this example. What if we have x squared and this is your function? Let's try to find the limitation of your function, okay po, as x approaches to 2. So therefore, from the identity, you know you have the same variable. You just substitute the value of your x as 2. So it will become 2 raised to 2. And the value of your limit is simply as 4. Okay po? That is our power function. How about for limitation has radical signs? Same goes by. So let's just say 30. Square root of 30. Okay. So from the square root of 30, or let's just say square root of 48. From the square root of 48, okay, can you think of something? For example, let's try to have this. This is simple as, let's just say, sige po, x. Alright. And we are trying to find the limitation of your function, which is square root of x as x approaches to 48. Sige po. For example, ha. And similarly, this is identity function, correct? Identity function, limit of identity function, again ha, limit of identity function here, okay po. And we know that your x is 48. Okay po? Limit of your x is 48. Alright. So, from your x as it is 48, you will going to substitute it as 48 square root of 48. And what is the value of square root of 48? Alright, this is not the final answer. Okay, how is that one? What is the factor of 48? We know that the factor of 48 is 4 times 12, right? Correct? And that could be distributed as square root of 4 times square root of 12, correct? And what is the square root of 4? What is the square root of 4? You know that it is 2, correct? And 2 times square root of 12. And what is your 12? Is that the final answer? Not yet, because what's the factor of 12? What is the factor of 12? It is 4 times 3. Alright, so therefore, you could have square root of 4 times 3. And what is square root of 4 times 3? Okay, is 4 a perfect square? Yes, it is a perfect square. So therefore, what we could have in here is that 2 times, instead of writing it down as square root of 12, that would become 2 times 2 times square root of 3. And we know that 2 times 2, it is 4. So 4 square root of 3. This is your final value for your limit. Alright? Okay. So here. Alright. So that is the properties of the basic, that is the basic limits, no? In order for you to understand more, I want you to be aware of what are the properties of limits. Here are some properties of limits. Alright, so we have the first property, which is a scalar multiple. Scalar multiple, as you can see, no, we have the constant number, which is the b. And when we have f of x, or your function, you are going to put your limit between, no, the function and the constant. Okay, so let's just have this example. Let's have the values of 5x plus 3. Alright, so this is your function. And you have the 5x and you have the 3. How are you going to find? I know that this is just simple as it is, no? Because you're thinking that this will be just simple as direct substitution. But in reality, no? But in reality, you're not just going to simply substitute it, but you're going to show that you should supposed to put the limitation on each function. So for example, this is your function. This is your function 5x, ha? Now, from your function 5x, what's the limitation of your function as x approaches to 2? This is not going to be simple as 5 times 2, ha? That's not just the thing. But the right process is to tell, no? If you will notice in your 5x, this is a monomial, correct? So from your 5x, you have a variable and a coefficient. Now, a coefficient, no? A coefficient could be a could be represented as a constant number as well. Knowing that, what is the definition of a coefficient? Coefficients are constant number that are being multiplied to a variable, correct? So coefficients are a constant number, correct? So therefore, what we could have here are two values. Okay po? So if we are going to find the limitation of 5x, this would be simple as limitation of 5x, correct? Now, you are going to distribute that one into such function to your variable. Okay po? So, it will become 5 limitation of x as x approaches to 2. Alright po? So, if you will notice, the constant are the left side of the limit. Okay? So, you just inserted the limitation between the coefficient or and the variables po. To tell that, no? To tell that you are finding the limitation of your x. And this is what we have for scalar multiple po. Okay po, this is the scalar multiple or the property number 1. Okay po? Alright, so what if, Sir Jai? How are we going to deal with such values like 5x plus 3x? Let's just say, let's combine terms. 5x squared plus 3x plus 2. For example, no? Now, if we're going to find the limitation of this function as x approaches to 2, yes, it is simple as you are going to substitute it. But to show it, no, it seems like you are going to distribute the limitation to each terms. Alright, so you are not seeing it. So you're going to substitute the limitation to each terms. Okay po? You have 3 terms, correct? So therefore, you are going to substitute it. Are you clear? Okay. So, let's try to substitute it already. And to distribute it. Okay po? So, for your first term, which is 5x squared, it would become 5 limitation. I'm sorry, pardon with my writing. Alright, so we have 5 limitation of what? 5 limitation of x squared. Okay, 5 limitation of x squared. As x approaches to 2 plus 3 limitation to x as x approaches to 2. Alright, so do we still have more? Yes, we still have more, and that is the value of 2. With that case, we should still have this limitation of 2 as x approaches to 2. From the first part, we could see that it will just simply substitute the values of your x, and that would become 5 multiplied by, what's the value of your 2? What's the value of your x? That is simple as 2. Multiplied it to itself, and that is squared, plus 3 times, I'm sorry, okay, 3 times x. What is the value of your x? The value of your x is simple as 2, correct? Plus, what is the value of your limitation of 2 as x approaches to 2? Nothing but the constant itself, 2. Alright, so we know that from your thing, we still have this terms po, right? So 2 square root, that is 4. So 5 times 4, the answer is simple as 20. Plus 3 times 2, the answer is 6. Plus 2. So therefore, 6 plus 2, the answer is 8. So in total, 20 plus 8. So the value of your limit in here is simple as 28. Alright po. So if you will notice, the one that we have made is the property number 2, which is sum or difference po. Okay? So, how about for the next term, Sir Jai? So for the next term or for the next property is the product. For example, you have 5x squared multiplied by 3x. I'm sorry. So we have 3x. So from your 3x, that is being multiplied, and this is your function. Alright, so as your function will be set up with the limitation as x approaches to 2, that will become 5 limitation. Okay po. Let me have this one as straight as this. 5 limitation x. What is your x? That is 2. Correct? But at the first place, please don't show it yet. Okay po? I want to see the process of getting the limitation on the process of your here. Alright, so here. Alright, so this is your function. right? So you have 5x squared as x approaches to 2, right? So from your other side, you're going to distribute to both terms. So as we have 3x, so that is 3 times the limitation of x as x approaches to 2. Okay po? So in that case, we know that what is 5? What's the value of your x first? That is 2. So that will be multiplied to 2 square. Okay po? But still, you need to multiply that one. So that will become 3. Okay po? And what is the value of your x? That is 2. Right? So therefore, it will be multiplied by 2. Alright, so that's why we have 5 times 4 and the value is 20. But then, you still need to multiply it by 6. And therefore, 20 times 6 is what? 120. So therefore, the value of your limitation for this given is 120. Simple as that. For the quotient, same goes by as what was the process as we have the multiplications. Alright, so once we have 5x squared all over 3x, as we get the limitation of this function as x approaches to 2, it will become 5 limitation of x squared as x approaches to 2. You need to indicate and to show the limitation of this function for your numerator. Alright. So what is your function, or what is the denominator of your function? It will become 3 limitation of x as x approaches to 2, right? So in that case, no? So in that case, it will become 5 times 2 square, correct? All over 3 times 2. So it has the equivalence when when we square this one, it will become 5 times 4 all over 6. And we know that it is 20 all over 6. And what is 20 over 6? The final answer, what would it become? It is 10 over 3. Or you could have 3.3333, correct? So you could just simply have this part, as this will become your value for your limitation. Okay. So what we have in that part is the quotient, or the fourth property, no, of the limitations or the properties. And for the fifth property, that is for the power of what we are doing since a while ago. For this one, this is for the fifth property. Okay po, that is our power. Now I want to show something to you, no? Like, not all the times that if you are given a function, you are going to directly substitute it, no? In a way that you should look for your function first, no? If it has value, or it is undefined, or it is indeterminate, or it is 0. If your function, for example, you have square root of x, no, minus 1, I'm sorry, let's have this one, all over x minus 1, wherein if you're going to get the value of your limitation as x approaches to 1, okay po, yan. Alright, so what would be the value if you're going to substitute it? What do you think? Mm-hmm. It will become, if you're going to directly substitute it, it will become square root of 1 minus 1 all over 1 minus square root of 1. And what is square root of 1? That is simple as 1 minus 1 over 1 minus 1. And what is 1 minus 1? That is 0 over 1 minus 1. That is 0 as well. And that is undefined. You can just simply put undefined in there. So what we could do in this part is is to look for something else first before you substitute it. How are we going to find, or how are we going to change this function first before we substitute it? What do you think? In order for us to change this function to something else, we could conjugate this one, no? Conjugation or conjugate. We are going to multiply the numerator and denominator from the value of your numerator. It has the radical sign, correct? So we are going to multiply it, but to its value, no? But it contains different operation po. Alright? Pardon? Okay. All over x plus 1. Alright, so therefore. Alright, so once we have this two terms, we know that numerator to numerator, denominator to denominator. What is your first term? Your numerator is a binomial, correct? So your first term is square root of x. The second term is 1, correct? So therefore, this is a binomial. When you are going to multiply a binomial to another binomial, you can FOIL it out, correct? So first term to first terms, outer terms, inner terms, and last terms. So what is your first term? Square root of x. What is square root of x times square root of x? Square root of x multiplied by square root of x. That will become square root of x squared, isn't it? But we know it is square, so that will be cancelled out. So therefore, when we are going to multiply square root of x to square root of x, the value would become simple as x. Okay. So, what is your outer term? The outer term, square root of x multiplied by the positive 1, that will become positive square root of x. Inner term, negative 1 multiplied by square root of x, that will become negative square root of x. Negative 1 multiplied by positive 1, that would be simply as negative 1. Alright, so with these two terms, we could cancel this out already. And we could have what? X minus 1 all over. Can you FOIL this out still? Yes, you could FOIL out that one, but I'm telling you, it would be better if you will retain it in that formation or in that form. Now, we have x minus 1 multiplied by square root of x plus 1. Okay? X plus 1. Pardon? Alright. So, when we have this one already, you could see that we could still cancel this one, right? So, we could have 1 over square root of x plus 1. So, do you think that this function will be the final already? Or the final function that you could have before you substitute? Yes, you might have. Why? Because when you substitute the value of your x already to this function, what would be the value? So that will become 1 over square root of 1 plus 1. And what is square root of 1? That is simple as 1. And 1 plus 1, that is 2. And your final answer is 1/2. simple as 1/2. So therefore, not all the time you are going to find, no? You are going to find the value, no, of a certain what? Of a certain function from the limitation. All right? All right. So next, let's have this one. Square root of, I'm sorry, you cannot see this one. All right. So t square. So let's have this one, square root of t square. Oh, that's not t square, but only t. Okay po. T, then you have 3. Okay po, minus 9. Okay po. Wherein, if this is your function, for example, this is your function, no? And if we are going to find the limitation of this one, no? As x approaches to, let's just say 3. Okay po. What would be the value of this function? If you're going to directly substitute it, that will become, I'm sorry, I'm sorry. So this is 9. Alright, so what if we make it as simple as, no, not that one, but this one. Let's have this one. This is 3. And this should be 9. This is 9. Alright. There you go. So if we're going to substitute this one into direct substitution, the value of that one would become square root of 9 minus 3 all over 9 minus 9 minus 9. Correct? And we know that, what is the square root of 9? What's the square root of 9? The square root of 9 is simple as 3. Correct. Simple as 3. So therefore, you will notice that your numerator has the values of 0 and your denominator has a value of 0. And that is undefined. We cannot accept that your function or the limitation of your function will have undefined. So from your square root, or I'm sorry, there should be t, rather t, no, instead of x. T minus 3 all over t square minus 9. Minus 9. There. Wherein, if your limitation is approaching t is approaching to 9. Yeah. Now, before we deal with this one, I want you to instill in your mind that you need to find something else before, or change this function to something else before directly substituting it. So if you're going to find for it, you could simply conjugate this function by multiplying the numerator and denominator by the value of your numerator, but has different, or contains with different operation, right? So you have t, instead of putting subtraction, that will become addition, plus 3 all over t minus 9. Okay, so in that case, if we are going to find the product of these two fractions, that would become x minus 9, isn't it? Alright, so x minus 9 all over, I did a shortcut of it, Maybe you could FOIL the first and second binomials. This one and this one. You could FOIL that one. No? And the final answer will be x minus 9 only. So how about for your denominator? You could have x minus 9 multiplied by not x. I'm sorry. That should be t. Okay, probably because it's t. Okay, t. All right, so that will become t. This should be plus. I'm sorry. Here, t plus 9. Correct? So in this case, you could see that we could cancel this out, right? So you could have 1 over t plus 9. And what is the value of your t? 9. In this case, you could substitute it already because there will be no restriction at all and it will not become undefined, indeterminate at all. Okay, so if you will be substituting it, that will become 1 over 9 plus 9, and that is 1 over 18. Alright po. So in limits, we do direct substitution with the properties itself po. Okay po. But please do take note that there are times that you should find ways how to change your function first before substituting the value of your x. Okay po? Alright, so these are the basic examples of our limits. Okay, so let's have this example. From your A, this is just simple as directly substituting. And this is our basic limits, right? Alright, so this is from the power or the fifth property. Alright, so next example. So from your limitation, as you will notice, we simply substitute it. But before substituting it, we distribute, no? Or we multiply the limitation for your 5x. Okay, so it's, if you will see, we inserted the limitation between the 5 and x because 5 has the constant value already, isn't it? So it is just simple as 5, but x doesn't have yet values. So therefore, if we are going to find the value of that one, that would become simple as 5 times 4. And we know that is 20. Now, we could say that this is the property number 1 because we know that the property number 1 is just simple as scalar multiple. Okay po. Alright, so for the next item is this one. If you'll notice, I know it's tried already. No, this is one of the examples. No, but I want you to show that from the process that we have, it is from the property number 4 po. Okay, what is our property number 4? That is our quotient po. Okay, because we have this numerator and denominator that are being divided to each other, right? So the tangent x and the x on your denominator. Next, let's have this next given. If you will see, it's on the radical sign. Okay po? What is that limit? From the radical sign, from the basic limits, it is the limitation or limits of radical function. Correct? Radical function. Right? Okay. And that will be simple as direct substitution. Alright, so how about this one? This is x cosine x. So x cosine x, this is just simple has two values because cosine x is just one value itself, wherein we are multiplying the x to your cosine x. Now, it seems like you're going to distribute the limitation to both values. So therefore, you could have limitation of x as x approaches to pi multiplied by the limitation of your cosine x as x approaches to pi. And I'm just showing some trigon, but most especially we're going to deal with the basic numbers, not with the trigon. And this could be found with the property number 3, and that is, what's our property number 3? That is product, right? Okay. So this last example, all right, we could have limitation of x plus 4 squared. Okay po. So if you will notice, this is a combination of two properties. No? That is the sum and difference and the power. Right? So the first place, you have two values and that is binomial. Correct? So once we have limitation, please, first is to distribute it. So you're going to multiply limitation times x and the limitation to your 4, and that will become limitation of x as x approaches to 3 plus limitation of 4 as x approaches 3. We know that 4 is a constant, so therefore the answer for that one will become 4 only, right? So in that case, if you will notice, if you're going to directly substitute it already, we could have 3 plus 4, and we know that is 7. And what is 7 squared? There is an exponent, take note. That is simple as 49. Alright, so if you will notice, I just showed you some direct substitution and some function that should be changed at the first place so that it will not become undefined. Okay po? Then you will be substituting right after if it is possible already. Correct? But also I also showed some of the functions that composed of two properties, okay, or a combination of properties, okay. So I do hope that from this video you learned a lot and you were able to find the concept of delimitation from the first topic or from the first discussion that we have from these limitations. Now I do hope that you learned something and you got all those things from our meeting last time, no. And if you have some questions, comments, please don't hesitate to put that comments and questions to the comment section. And please hit the like if you like this video. And let us see next meeting. Alright, so let's see next video. Thank you and God bless. Thank you for watching this video. Bye.